A student who starts designing web pages pays a one-off cost of $250 for the setup of software. We can see that just here. If he doesn't produce any web pages, he still pays $250. He estimates that each web page will cost him an extra $30 for various online costs. Now we can see here we're going up in 2 web pages. So at $30 a web page, this is going to go up in 60s. So we need to complete the table. So we're going to go up in 60s, so that's going to be 370, 430, 490, 550, then 610, 670, and finally 730. And we want to draw that on the axes. So 0 to 50 is just here. Now this is a straight line, so choose another convenient point, 10 and 550. So that's just here. And let's draw a straight line through those two, like so. The student plans to charge customers $50 for each completed web page. Complete the following table, which lists the revenue or income obtained from selling N web pages. So $50 a page. If he doesn't sell any, he doesn't make any money. And then these are going up in 2s. 2 lots of 50s are 100, so these are going to go up in hundreds. So 200, 300, 400, 500, 600, 700, 800. And then we want to plot this one. So let's do it in a different color. So 0, 0, 16, 800, and let's draw that on like so. Got it a little bit low actually. Let's just do that again. So we'll make sure that it joins onto that one. And it joins exactly onto that one. Like so. So given that profit is revenue take away cost, use your graph to find how many web pages need to be designed in order to show a profit. So revenue take away cost. Revenue is red on the graph and cost is blue. So we're going to show a profit if red is above blue. Now they seem to actually cross over somewhere around here. So if we come down there, that seems to be somewhere between 12 and 13. It's difficult to tell when we have really poor axes like these with not many points on them. But it seems to be between 12 and 13, which means at 12 the red one is below, so we'd make a loss, and at 13 it's above, so we'd make a profit. So I'm going to say that we have to produce 13 pages. We want to state the linear function that relates C to N. So C, remember we're looking at the blue one here, the y-intercept is at 250. Every time we go 1 unit across, this one goes up by 30. So the gradient is 30, so it's 250 plus 30n. The linear function that relates r to n, so the intercept is at 0. Every time we go 1 across, we go 50 up, so that's going to be 50n. What are the coordinates of the point of intersection of the two lines? Now that's what we estimated here. We can find it exactly now we have the rules. They intersect when r is equal to c. So 50n is equal to 250 plus 30n. Subtract 30n from both sides. 20n is equal to 250. So n is 250 divided by 20, which is 12.5. So n is 12.5. Substitute back in. It's easiest to substitute into r. R is going to be 50 multiplied by 12.5. Now I can tell you that this will be 25 times 25, which is 625, but just to demonstrate that, 50 times 12.5 is 625. So our coordinates are 12.5 and 625. Work out the rule that gives the profit from the number of web pages sold. So we know that profit is revenue take away cost. Revenue is 50n, and then we want to take away 250 plus 30n. Expanding the bracket, that's 50n, take away 250, take away 30n, which is 20n, take away 250.